Section 26.1, the solar system and its formation. So in this chapter, we're going to talk about the solar system and pretty much everything that it contains, which includes obviously the sun, which is the star, the planets that orbit the sun, and then additional extra leftover stuff, right? So dwarf planets, asteroids, comets, meteors, and so we'll talk about all those things in this chapter. When we talk about the planets, we divide those generally into two classes. We have the inner planets, which are Mercury, Venus, Earth, and Mars, and then the outer planets, which are Jupiter, Saturn, Uranus, and Neptune. Now, before we get into the components of the solar system, it helps to kind of understand where the solar system came from. And this is how a lot of the solar systems in other places would generally form as well. The idea is what's known as the nebular theory. This theory basically states that the sun and all the planets formed from some cloud of gas and dust that was just sitting somewhere in the galaxy. That cloud of gas and dust, we call those things nebulas. At some point, some event occurred. Maybe it was a supernova or something that caused a shock wave to travel through this region of the galaxy. At that point, the gas and dust that was that nebula gets stirred up, and as it does, gravity starts to pull it all together. Because of a quantity known as angular momentum, as the dust starts to pull in, the material then starts to essentially rotate and spin. The more stuff comes inwards, the faster it spins faster and faster. This is very much like when you see something like a figure skater and they're spinning and they pull their body, their arms and their legs in and they start spinning faster. It's the same general idea in terms of angular momentum. That as this mass collects, the angular momentum of it starts to spin up because the mass is more concentrated. At that point, that spinning cloud starts to gather a lot of mass in the center. That center starts to bulge from the disk. So as the object is spinning, right, it starts to flatten out into what is essentially a plane almost. And you have a bulge in the center that is a star, and you have then a plane of dust going out towards the solar system, or going out towards the galaxy, I guess. As time goes along, the mass in the center, that is the star, we call that the proto-sun before the sun starts fusion. That mass eventually will have enough mass to start fusion and turn on, and the sun turns on, and when it does, a lot of different things happen in the inner and outer solar system. The sun turns on. At that point, leftover gases and things like that within the inner solar system, so say near Mercury, Venus, Earth, and Mars, those extra gases, like helium and hydrogen that are near the sun, they are either essentially torched by the sun turning on, or they are blown away by the energy of the sun as it pushes all that stuff away. What is left behind is smaller particles of dust. That dust will start to accumulate over time through gravity. A couple pieces collect, and then as it gets closer to another smaller piece, it pulls that towards it, and over time, those chunks of dust start to form small rocks, which we call planetesimals. And then as those things accrete more matter and gravity begins to structure them, over time those planetesimals become planets. And what you see in the solar system then is that in the inner solar system, there are 4 rocky planets made out of silicon, oxygen, dense elements. In the outer solar system, you see that you have, where those gases were not blown away by the sun turning on, you see that you have gas giant planets, Jupiter, Saturn, Uranus, and Neptune. Very large planets, but mostly made up of gases and not of solid material. And so the sun really differentiated the entire solar system. And you're going to see that the sun plays a huge role in the way the solar system formed, but also just how things behave in the solar system.